great deal of interest in local generation, domestic level generation. And for us, that's going to create technical issues in the electricity network of localized voltage rises and the need for managing a two-way power flow. What used to be for us and has been for a generation is a very highly predictable one-way flow of energy. Comes in from national grid, comes down through our system to our customers, highly predictable, highly readily manageable, load shapes and demand profiles predictable from one day to the next, from one season to the next. That could all change. It's very likely to change because there will be localized generation. That's going to depend on variations in the weather, wind, sun, and indeed local consumption. And again, picking up the example we've just seen there, as that generation is taken at a local level and consumed as a local level, traditionally where we've had a perfect view of the load requirement on our network, there will now be so-called latent demand on the network, hidden, whereby there will be that consumption in the network, but we won't be providing it. So in situations where that demand can be required from our network, that if depending on the variation in the weather, then we also have to be aware of what that latent demand is, what its likelihood of appearing is going to be, and we have to build our network to actually meet that demand if it's required. But sounds like lots of technical problems. There are huge numbers of opportunities in here as well. And what we have there is, if there are things like the biomass station coming in here, where we have sufficient distribution of this source of local generation, then we can possibly start to take a probabilistic view of if that generation is going to be there at any given time. Can we rely on it rather than have to increase the supply, the capacity of our network? If we can do that, that's a huge benefit again to offset potential as a potential store as well. And then finally, the renewable heat energy incentive, which is being described as a likely addition next year, is going to stimulate, again, a great deal of interest in heat pumps, which will also have implications for us. I'll touch on that in a minute. Electric vehicle charging, it's not Kent, for which I apologize, but in London, the mayor has committed to 25,000 electric vehicle charging points by 2015. Nissan are committing to large-scale production of electric vehicles. I believe there are others following suit. And those electric vehicle initiatives are appearing in other cities as well. We're going to have to, it will inevitably require additional infrastructure to be laid. Not for everything, I'm sure, but there will be cases where we need to provide additional substations and cables. But we're doing some research. We've already done some research on what does an electric vehicle economy start to do to our network, and how can we actually meet that challenge, indeed, before it's here. How can we design in what we need to do to offset our network consequences? And this is 2 slides just to show you the research on electric vehicle charging. If we did conventional usage of the electric vehicles, and this assumes a mass of vehicles and its effect on a daily load cycle here. And you see on the left, if everybody drives home from work, and of course the first thing they do is park the car and plug it in. Now, if we did that without any control at all, there would be a spike in demand as that charging took place. We're already seeing if we're able to adapt some smarter control of that charging, then we can actually spread that charging period over the assumed period during which this vehicle is parked. I mean, a bit tough if you go down to the theatre afterwards, but I'm sure we can manage that one. But that will spread the charging energy through the nighttime period and therefore avoid the need for system reinforcement. Similarly, one drives a car to work en masse, plug in at your workplace charging station or whatever, a morning peak would appear without smart control. With smart control, that can be spread across the working day. Now, again, in this model, there is a slight increase in the overall demand, but it's a very significant reduction against that peak, which we would have to provide otherwise. And just a very quick discussion on heat pumps. Again, the research which has been done on the assumption of the influx of heat pumps into the economy. And this is a daily load cycle, national daily load cycle. So again, on the left, the assumption in the modeling that was done was the heat pumps, electrically driven heat pumps, of course, would simply be delivering heat as required. Do you see here? It's a huge addition to the already, to the existing demand cycle. So it's already obvious that heat pump systems are going to need some form of heat storage within them to iron out those peaks. So again, on the right there, the model suggests that if we're able to add some heat storage into the heat pump system, and just to anticipate any questions, I don't know any detail about that at all, I'm very sorry. But it's to show that through smart control, we can actually suppress those peak demands. But we can see that they're coming, so that's feeding into how these systems are going to have to work and how we're going to have to react to them. So just to summarize that bit there, our network has to deliver the peak demand which is required. Through smart control, we can flatten out those peaks. That technology already exists. It just needs to be obviously refined and brought in. We continue to look at ways to avoid expensive network reinforcement, and we're also researching active network management. In response to the challenge, for this 5-year period, the regulator has brought in the Low Carbon Networks Fund for all of the industry to access, to develop large-scale demonstrations of the sort of technical innovations which are required to meet this future. And I'm just going to talk about some of the innovations which we've brought in, and also a commercial future that we have as well. 2 minutes, right?